Today we are going to have a little discussion about the system noise temperature and basically the gain transmission ratio. Important that what kind of a gain we are having and energy related with this one. This is all about the target we are going to work today. See, as we are working to design up a link specifically, so many parameters are there which always works with it. So many parameters are there. Among them, we have to take care about the system noise also. And definitely that's very important aspects. If we go here, let's see what is exactly the noise and noise temperature. So we know that so whenever unwanted signals are there, and then unwanted signals are having a part of a you can say like of your device, your transmitter or receiver, and if they are the part of this one, then it happens, and it happens in a situation that such kind of devices, such kind of networks may create an issue related with the creation generation of noise, and with respect to generation of noise they just rise up a certain temperature. So if we go here by this reading it all, one can easily find out that noise temperature helps to the determination of the noise. If you go here and just have a look of this one, this tells you noise temperature provides a way of determining how much thermal noise is generated by active and passive devices in the receiving system. So it's a very simple, because you are working to connect two satellites or a satellite with a ground station. So while you're talking about the connection in between these two, while talking about the connection and having such a situation here, so if a receiver, the receiver which is at the satellite, the receiver which is at the ground station, in both the condition, it might have a chance to receive not only the signal but the other nearby signals too. That is a possibility. That is exactly the chance. And to just avoid this possibility, to just avoid this chance, we are just working to read out this noise. That exactly. So let's see at microwave frequency, a black body with physical temperature Tp degree in Kelvin generates electrical noise over a wide band. What they're saying simply microwave frequency. It means a frequency which is in the order of the 3 to 300 gigahertz order are there. Under 3 to 300 gigahertz order, a black body with physical temperature Tp. Let's say we have a simple a black body. It means what exactly inside that body? Not clear. But it is simply a piece, something, some object is there. So when this object is here and it receives Tp degree Kelvin, generates electrical noise over a band. It can generate electrical noise, it means electrical signals, radiations. And that noise can be calculated with respect to of this one having a power. If suppose it has a certain temperature, so it can be related with the Boltzmann constant and directly it can be calculated through this. This is simply telling you if you have any process by which if you are getting a receiver's temperature a bit high, so with respect to that noise temperature, one can easily get the power of noise which is being created. So that's important. So here we have the K as a Boltzmann constant, we have a Tn as a noise temperature, we have a B noise bandwidth. So that's all can be related with each other. If you see here, the power is proportional to T. So whatever the temperature rise may be there, and according to that temperature, simply this particular device, particular receiver will show up that how much noise is being generated. Exactly the important part. System noise temperature TS is the noise temperature of noise source at the input of noise receiver, which gives some noise power as the original receiver measured at the output. So talking about this noise, because we have already studied about that, we have already talked about that, this noise can be into two parts. The one which is related with the system noise, it means the internal, and one is the external. If receiver is there, so there might be two chances. Simple. What are the chances? That receiver may receive some of the signals from the nearby zone. And while talking about its own system, its own device, so it might be possible that this particular system may have a chance to create its own noise. So that exactly they called as a system noise. And the system noise temperature is denoted with the TS. I'm just clearing it back. So we are talking about the noise temperature. The noise temperature is to be taken as Tn, which is because of noise. If the noise is being created by the system, it is taken as Ts. And importantly, this is exactly proportional to the power. One can easily find out, knowing the value of the temperature, can easily go for the calculation of the. This is exactly important. So this is a very simple kind of a process by which you can calculate the noise. This is a simple block time. We are going to work more with that, and we are having certain equations. These equations going to help us. So nice. We have this important point, noise figure. So this noise figure, so important, very important. So if we are talking about the communication system, any kind of the communication system is here. This noise figure is a very important factor which tells you that particular communication setup is going to work or not, because it depends upon noise figure. And this noise figure is deciding on the basis of each and everything related with transmitter, related with the channel, related with the itself a receiver and all the systems. So before releasing any power from base station to satellite and satellite to base station, it means earth station, we have to find out that radiation and releasing in this power will have certain noise figuring. And that noise figuring is very important and that should be calculated. So noise figure is used to specify the noise generated within the device. How much noise is being generated? That can be calculated with the noise figure. And if a device is here, so it might be possible. Some of the noise may be a part of an input, it might be coming from the input side, and it might also be possible this particular noise, whatever the noise we are talking about, this particular noise may be generated within the system. So, important part, we have to take care about that, whether it is coming from the input side or it is being generated inside the system. If anybody is looking to find out this noise figure, that can easily be calculated. Find out signal to noise ratio of input. Whatever the signal is coming, just check its SNR. And whatever the SNR is coming out, check this one. So you can easily find out what is the noise figure of. Let's take an example. If suppose I'm just teaching you, I'm just taking this uh, lecture here on the online mode. So I'm just saying something and the devices are just getting a signal. And along with that signal, some nearby noises may also be there. You may find out some background noises may be there. And once these noises are being inbuilt, so first of all, we are having certain signal to noise ratio itself while I'm speaking, that it is creating something signal to noise. Because always in air, some sort of the sound signals are always. So it is being inbuilt and it is reaching to you. Now the second thing is here, we are using a device which device is itself creating a certain noise because it has a heat, it has a temperature, it has a signal processing, it has its own working abilities that is creating itself. So finally, thus output which is being put on network will have certain, because you feel person who is speaking before you directly without using a phone having a different voice, and once you listen the same person on phone that have different voice, different look type of voice, means you can figure out that that is the same person. But if you see about the contents and the quality of voice, so that happens in the case of the internet. So this is exactly called as an operational noise figure. And while we are taking and talking about to just connect with the satellite, that's much important, because if suppose you seriously do not talk about the noise figure of your transmitter, you're not talking about the noise figure of your receiver, sometime you may have a chance that you may lose your signal. So that's why this is a noise temperature and the noise signal has to be taken care of. Working up more with this one and coming up to next, we've already gone through this one. And the most important part, now we are just going to work with the downlink design. So as we are just talking about this all designing downlink and uplink. That's a very important part of a satellite. And most important, this designing, whether it is a downlink design, whether it's a uplink design, have a separate attributes. Means they have some similarities, but if talking about the link budget analysis that we have already gone through, if we talk about the link budget analysis, the link budget analysis is quite different in the case of list designing, link design or uplink. We see here. Talking about this one, the design of any satellite communication is based on a meeting a minimum C by N. It means whatever the signal we are just providing, so that has some channel capacity and we are having a noise ratio. That has to be a specified percentage of time, carrying the maximum revenue, earning traffic at the minimum cost. We have already talked. This is exactly the link work design, and we have worked on that. Any satellite link can be designed with very large antennas to achieve high C by N. So this high C by N can easily be achieved while we are working. What kind of a commercial effects are there? What kind of a power is there that you can achieve? But it will increase the cost. And once this cost is increased, so obviously that service is not going to work very nicely with this. Similarly, art of a good system design is to reach the best compromise of the system parameter that meets the specification of lower cost. So we are looking to create this all about the other lower costs. On that basis, we have just created this link budget analysis. We have completed through this one. So now coming up the same one. As we talked about the downlink design, we should have the uplink design. The uplink design is easier than the downlink since an accurately specified carrier power must be presented at a satellite transponder and it is often feasible to use much higher power transmitters at earth stations that can be used. Right. So the first important part, if we are talking about the downlink design, we are talking about the uplink design. What specification we have to carry forward? We have to think upon that during the course of the uplink design, during the course of the downlink design, we have to take care about that uplink design. Talking of uplink design and designing uplink becomes easier. It's much easier that we are talking about the downlink design because since an accurately specified carrier power must be presented at the satellite transfer, because we know that if suppose we are sending something from the satellite and just sending towards the satellite because it's going to the up, and we know that what exactly the distance of a satellite, we know that atmospheric situations are there, so calculation of accurate power is there. But because we are here we are calculating it manually, but at the satellite it's somewhat automatic, the machines are doing this. Well, when machines are doing it, it becomes a bit typical. Cost of transmitter tends to be high compared with the cost of receiving equipment in satellite communication. So if suppose we are talking about the transmitter and talking about the basically highly compared with the cost receiving equipment, so the receivers which are at the satellites having surely the receiver which are at the satellite having surely a high cost, and we are definitely having a low cost. We are talking about, so this is exactly the difference. So I talk about uplink and the downlink design. And uplink and the downlink design, we are having a big difference, and we have to go for this. So coming on this one. So next point, which is more important, we have talked about the downlink design. We are working with the uplink. So earth station transmitter power is set by the power level required at the input of the transformer. So exactly who is setting this power? Earth station. See, it's a very simple. It's a very simple that simple. You have a satellite, you have a earth station, you launched your satellite there. It's very same. Like you have a car with you, just take an example, and you want that car must give some commercial benefits to you. And you are hiring a driver and saying, this is my car. You just get it and wherever you want to take it and earn some money by making it like a cab. Now, suppose that cab is moving everywhere within your city, within your state, wherever you wish to work it on. So it's working all around. While it is working all around, you need to know that now where it is working from which the ride has been taken up. You have to take care about where the ride has been taken up. And when we are talking about this right, and that's important, you should have some kind. So buying a taxi, buying a car, putting a driver doesn't make that this is going to give a complete benefit to you. Now, yeah, what you're looking? You're looking that at least I must have a phone connection with my driver. So that where are you? So he tells you that I'm standing because I'm not getting no one. No one is here to pick me as a cab. No one is just asking me to go here. So there is no earning. So I'm just staying. Okay, fine. You do not have any options. Or it might be possible that the particular person who is in a cab say, yeah, it was a very small ride. I just went only for 2 kilometers. It could be possible he went for the 12 kilometers. So what else you can do? This is the communication link you are setting up. So phone call is not giving exactly idea whether your car is creating a good revenue for you or some mishappenings are there, some losses are there. So what you will do for that, you will try to go for the GPS. You will ask, just put a GPS system over there, and you have a tracking system that how much distance your car is covering. So now to increase the benefit from your car, what you are doing, you are creating a technology, you are using more effective systems within it. So that's all exactly the meaning of the setting up of a link. The same link setup is done in the downlink. Downlink, it means the power which is coming from the satellite to Earth, and the uplink, the power which is reaching from Earth to satellite. That exactly the meaning. Analysis of uplink requires a calculation of power. There is a requirement of power, transponder power, because we have a satellite, and the satellite once receives the power, it reshapes the power, it changes the frequency, it reconditions the power, and send back to the earth. So this is exactly, so link equation is also important here. So again, we have to go for to find out this link equation. The same kind of a link equation has to be created, and at frequency above 10 gigahertz, propagating disturbances from that has to be taken care of. What is the frequency that we already talked about in the previous lectures? We had gone through that. What is the application frequency and what are the losses? So we talked about basically all these losses. The lowers the uplink CN ratio is a transponder which lowers the overall CN by ratio in the earth station receiver. This is exactly the meaning of. So design of specific. So looking for this one, how you can go for this, what kind of values you're looking for, finding out this CN by ratio. So you have a number of options, number of the way how to design a specified, because for each and every link, you should have a very effective, whatever the channel you're using and you are having a noise. So this ratio has to be maintained very perfectly. And how much noise you can accept, how much noise is tolerable. So while you are talking about, you have to go for. If you see here, when more than one CNY ratio is present in the link, it might be possible. Within the link, you have a number of choices, number of the options are there. In all this situation, when this kind of situation happens, it might be possible if you have number. We can add individually. So this is giving a choice you how you can create C by N ratio reciprocally to overall C by N ratio, that denoted as C by N. Overall C by N ratios can be calculated by just taking their parallel combinations like that 1 upon C1, their reciprocals, and 1 upon. So this is giving you an average of all. So you have a different kind of a CN by ratios related with your design systems, and all this giving you a net. So this is the one process. So who is going to design this may have this value. Similarly, satellite communication link design process. This is very important. Let's have a discussion on that. So first of all, how we are going to design whether it is a uplink or whether it is a downlink. This is important. So determining the frequency band in which system must operate, compatible design may be required, help to make a selection. Very first important aspect. How we are going to work this one. So determine the frequency band. First of all, you have to choose your service, for what service you are working upon, what is your target, what is your field and area. That's all important. So first of all, you have to go for that exactly the first thing which is most important. is finding out the frequency band, whether you are working for mobile communication services, whether you are working for the GPS services, whether you are working for the military applications, that all depends upon. So, satellite communication link design. First of all, it requires this one. And comparative design may be required to help that we created the link budget analysis. Link budget analysis is nothing but a creation of table. Different type of tables are there that is giving, suppose you are using this transmitter, you would have that cost and you would have that benefit. Cost, benefit, input, installations, that all matters. And on the basis of all that, one can take the selection. Second point, determine the communication parameters of a satellite. Estimate any values that are not known. So exactly communication parameters. What are the communication parameters for what we are looking? Suppose that we have just taken an example of mobile communication and we want to use this mobile communication through satellite. So what exactly we need? What kind of a transmitter we need? What kind of a receiver we need? What kind of a transponder which converts the frequency? What kind of a transponder we need? What should be the power? What should be the feed line connection? What can be the losses may be there? Channel to noise ratio. So all these factors matters. So one has to create a complete list of that what are the parameters are going to affect my this communication. Important part. Now talking about the next one, determine the parameter of transmitting and receiving RTST. So first, we are choosing the frequency band. Then what kind of a communication we are going to? We have to find out all communication parameters. Then the step number 3, we are going to work with the parameters of the transmitting and receiving earth station. Transmitting and receiving, because we are transmitting from the earth using a satellite, and that particular is going to work again with where it is going to work at the position where again we have a receiver on it. We have to one, and second, satellite is supporting, so we have to find out the parameter of this transmitting station which is on earth, and this is the receiving station on the earth. So we have to check what exactly their nearby surrounding required parameters are there, that all has to be taken up carefully. Start a transmitting earth station, establish a uplink budget and transport a noise power, and in the transponder. So what we have to do? So first of all, we are creating a uplink. So that has to be created on the basis of C by N analysis that we have already worked. Now the fifth point. Find the output power of transponder based on the transponder gain or output back. So first, we have here power, we have just calculated everything. We are sending our signal to the satellite. At the satellite, what do we have? We have a transponder. At the transponder, we are receiving power and we are creating output. So we have to take care that this transponder, which is at the satellite part, is is creating what kind of a losses or creating what kind of a gain. Once this is known, what output it can provide, that is important, because it is actually the person who is just watching your receiver. It is exactly a device, it is exactly a system who is watching. It is going to give. Now you are not giving directly to the second station, you are sending your signal to the satellite and satellite is watching you. That has to be the. Establish a downlink power and noise budget for the receiving earth station. Calculate the C by N ratio, and for the station at the edge of the conversation, so again we have to go for this downlink power. Link budget analysis has to be done. We have to find out the basically channel and noise ratios. What exactly is here? Calculating this SNN or BER, bit error rate जो भी होगा, that has to be taken up in the baseband channel and link margin. Evaluate the result and compare with the specific requirements. See, after doing all this, you are calculating from the transmission, transponding, then receiving, and all this budget analysis. Then finally, at last, you just check, you put that I'm just putting that much of effort by means of technology, by means of, I can say, by means of you uh, money, everything is you're putting, and what is the service and benefit you're going to receive. That analysis has to be taken. Somewhere you feel that input is more, and the profit is less, you have to cut off the things. Exactly the process related. Well, today I'm just concluding my session. So my session is related directly with the design of the uplink and the downlink. So uplink and the downlink having only the one similarity, that we are talking with the satellite, and the talk of the satellite requires link budget analysis. This is the common. Rest of parameters related with them are absolutely different. The budget analysis content will be different. One has to take all these parameters. When these parameters are there, then what exactly the common and modified process that is to be taken into the consideration. And once all these things are okay, then you can easily set up your satellite from Earth to satellite and satellite to back on. This is exactly the overall process. So this is exactly, now the section is open. If somebody is looking for something, may raise the question. Let's see something. See this one. This is exactly showing up. A great traffic is being shown up here on the Earth, and having a large number of such satellites are working around. That situation happens. And we have among them some of them geostationary, some of them are rotating with their speeds, and it's like that. Geostationary is basically, so who is taking care about this? We have already talked about that. Is working on this one. So hope so. You might be able to understand this one. Somebody is saying in chat box something. All clear, no doubt. Well done, Yash. ठीक है, तो if you are all clear, then no doubt is here, because I feel बिल्कुल बहुत अच्छी बात है, और कभी कभी all clear situation clear वाली हो जाती है ना? Nothing is like that. Chalo, hope so. So nothing is here to ask. Yash is saying everything is fine, and I expect everyone is just getting this one. Or those are feeling this class we are having online, we are having a certain different schedules. So this is your own and honesty. ईमानदारी से, if you are learning, listening something, दो लाइन भी अगर सुन रहे हो, तीन लाइन भी सुन रहे हो, that might be okay. So keeping all these things,